What's up, math scholars? Thanks for joining me in another video. We're doing the Chapter 8 study guide to help us get ready for the test tomorrow. I've got a live audience in here. They're looking pretty awake and happy. So are you guys excited about the 4-day weekend and Valentine's Day? Woo, yeah! Woo! All right, everybody turn to number 1. You have your calculators ready to rock? What is the degree? Who remembers what a word degree means? It's 4. Well, thank you. But what does degree even mean? The highest exponent in any single term. Highest exponent in any term. So I'm looking at like this first term, its degree is 2. I'm looking at the second term, its degree is 3. This one's tricky. The y is to the first power, the x is to the third power. This combines to have an overall degree of 4. And then this term here would have a degree of 1. Now, you want to select the highest degree of any term, and that's why AJ selected degree 4. So it's degree 4 polynomial, okay? Number 2, we are doing a sum. What's the word sum mean? Adding. So we're going to add up all our like terms. We can use colors. If you have highlighters with you, this would be great time for your highlighter. We'll start with the m to the third. If this is negative m to the third, and this is 10m to the third, and we add them, it would be 9m to the third. New color. If this is negative 3m squared, and this is negative 4m squared, it would be negative 7m squared. New color. If this is a 2m, and this is a positive 6m, they would add up to a positive 8m. And stop me at any time if you see me making a mistake. If this is a negative 8, then I really don't have any other numbers for it to combine. Does that match what you guys got yesterday, those people that did the study guide yesterday? Yeah. Good. All right, number 3. What's the word product mean? Good. We're going to be multiplying. So you have your choice. Some people like doing the rainbows. That's called the foiling method. Some people like drawing the 2x2 box and doing the box method. So let's just take a vote. Who likes doing the rainbows and doing the foiling rainbows? Okay, who likes drawing the 2x2 box? Okay, looks like we voted rainbows then. First times first is negative 5x squared. Outside times outside is positive 40x. Inside times inside, that would be a positive because they're both negatives, positive 2x. And last times last is negative 16. How am I doing so far? Okay. Let me know if I'm going too fast. Our middle 2 appear to be like terms, so we'll be underlining them in the same color. And then I'll write my final answer. Negative 5x squared plus 42x minus 50. So far, so good. Number 4. Okay, so for this one, it's a subtraction problem. These are probably the hardest ones. I actually think the subtraction problems are harder than the foiling and the multiplying problems. You want to take this negative sign and distribute to everybody. So it will become a negative 4s squared. 2 negatives will actually turn that 3s to a positive. And then a negative times a positive 1 is a negative 1. Your first binomial is not affected, so the 7s squared and the 3s bit just remains the same. And now I'm going to take my colors to add up all my like terms. So I've got a 7s squared and a negative 4s squared. I'll make those blue. That would be 3s squared. How about we'll do black next? 3s and 3s is 6s. And the only thing left is this negative 1. Is that answer looking like what you guys got yesterday? Yeah. Yay. We're doing good so far. Oh gosh, that means I have the wrong answer on my paper. It's not what I have. I'll have to change it and re-scan it. Okay. Number 5. What are the solutions? This one, when I did this one this morning, it was a little awkward to me. Traditionally, when you're solving something, there is an equal 0 sign over here. So if you're looking for the solutions of this, you're going to have to make the equal 0 yourself. Normally that is provided, so that is a little strange. What factoring method will we be using to solve this? Old-fashioned factor technique. That's my favorite. Actually, I like grouping the best, but What numbers multiply to negative 55 that add up to 6? 11 and 5. Yep. So we're going to make the 11 the positive and the 5 the negative, so it can add up to that positive 6. All right, at this point, we use our zero product property to set each of these binomials equal to 0, so that I would write x plus 11 equals 0, or x minus 5 equals 0. And you'll solve both of those equations separately from one another. Okay, so minus 11 would be x equals negative 11, and then plus 5 would give me x equals 5. And you put an or between the two answers. All right, number 6, we just talked about this in the warm-up today. This is a section 8-7 problem where you're going to use your square roots. They're both perfect squares. There's a minus in the center. That's what kind of alerts me to the fact I'm going to use the square root technique. What's the square root of 16x squared? Good. And what's the square root of 49y squared? 7 and a y. Just make sure that one has a plus and one has a minus, so it would FOIL back out correctly. Yeah, for these perfect square ones, yep. All right, we're doing good. We're flying through. All right, 7. On this one, you could definitely use your rainbows, but it's going to have so many rainbows that you'll just have a lot of terms. There'll be 6 terms. So personally, I always vote draw in a box when the problems get this big. So I'm going to draw myself a 3x2 box. If you don't like the box technique, just use the rainbows on your paper. I'll do a 3k squared, a 5k, and a negative 1. And I'll do a k and a 4. Then we have to multiply these. Okay, so my upper left box will be 3k to the third, 5k squared, and negative 1k. It's technically negative 1. I just have the 1 invisible. That's allowable. This bottom right box, bottom left box is 12k squared, 20k, and negative 4. And now I love the box method because it normally has your like terms diagonal, and that is the case here. So to express my final answer, it would be 3k to the third, 17k squared, 19k, because it was a 20 with a negative 1, and then a negative 4. How are we doing? Am I going too fast? I can always pause the video and let you write over it. On this next one, the biggest mistake I see is people think that the squared can just distribute in as not allowable. What this math problem actually is about is taking an a plus 7 and multiplying it by another a plus 7. So I think we voted rainbow method on 2x2 binomials, so we're going to do our rainbows. A times a is a squared. A times 7 is 7a. 7 times a is another 7a, and 7 times 7 is 49. Those two then would add up to 14a. Scroll ourselves a little bit. Factor out the greatest common monomial. I had some people come over and ask me about this problem yesterday, and I truly believe what was throwing them off was these parentheses. We've just never seen parentheses on a greatest common monomial problem. So I don't know why the teacher that made the study guide put the parentheses there, but you could ignore the parentheses. They really don't do anything. What is the biggest number that you can divide out of 18 and 27? I agree. How many x's do both terms have in common? How many y's do both terms have in common? And how many z's? Yeah, so that was actually pretty easy. And I'll make myself an empty set of parentheses for what I'll have left. 9 times 2 would give me that 18. If I had 3 x's and took 1 away, I'd have 2 left. If I take that y away and take that z away, there's nothing left in that first term. Negative 27 divided by 9 would leave me with a negative 3. The x would be gone. One of these y's would be gone, but one would be left. And then this c would be gone. I think that's it. Does that look like what you got yesterday? Yep, that's what I had in my paper. Scroll ourselves down. Factoring. Ooh, I'll leave that in case you're still writing. Okay. Factoring techniques. Number 10, what factoring technique would we use? Old-fashioned. I agree. We're trying to multiply to a negative 36 and add up to a negative 9. So 36 and 1, 9 and 4. What were you going to say? Negative 12 and positive 3 is correct. Oop, positive 3. There we go. All right, let's do 11. When I looked at 11, it's that negative out front that really caught my eye. You don't want to attempt to affect these problems with any negatives out front. So I actually started my process by pulling a negative 1 out from all 3 terms. So if you pull your negative away from your first term, you're left with a positive p squared. If you divide a negative 1 out of your second term, you'd be left with a negative 8p. And then you'd be left with a positive 12. So pulling a negative 1 out just turns everybody to the opposite sign as they were before. And you're left with just a normal old-fashioned factoring technique at this point. So do you guys know what numbers can multiply to give me that 12? Yep, both of them are negatives. So a negative 2 and a negative 6 would multiply to a positive and add up to a negative. All right, when I first looked at number 12 this morning, I was like, oh, sweet, I'll factor a 3 out and get myself going. But that 19, unfortunately, is not divisible by 3. So I think we just have to head straight to our box method. What goes in our upper left box? Perfect. What goes in our lower right box? Perfect. We multiply those together and get 18. So I circle the 18 and scribble out the 8. I want to multiply to get an 18, but add up to get a 19. Those will be easy numbers to come up with. Good. 18 and 1. And it doesn't matter which ones where you put it. I'm going to put my 18 here. If you put your 18 down here, you'll still get the same answer as I will. You'll just have different people in each row and column as me. Right. Biology time. Punnett squares. My first two rows have, or my first row, these both boxes have a 3w in common. So now I'll work my way around the square. 3w times what is 3w squared? 1w. 3w times what is 18w? 6. And then w times what is 1w? And I just checked that 1 times 6 is 6. So that was not bad at all. 3w plus 1 and w plus 6. There's your final. All right, I ended up helping a lot of people in my 7th period class on 13 because they were just kind of stuck. They were trying to box method this right off the bat. You want to do a common monomial first before you attempt box method. So do you know what the common monomial is? Not 4. 4 is a good idea, but this guy doesn't have a 4. So it has to just be a c. And that leaves you with 4c squared plus 4c plus 1. And now you can head to the box. Let me erase that random dot so you don't think it's a negative sign. Box method time. Put our 4c squared here, our 1 here, multiply them together and get 4. That's the number I'm going to circle. So we need to multiply to 4 and add to 4. Good. So 2c and 2c. It's one of those like perfect square type of things. In my top row, it's a 2c. Now we'll work our way around. 2c times 2c is 4c squared. 2c times 1 is 2c. And 2c times 1 is 2c. And then, of course, 1 times 1 is 1. So if you want to write your answer super scholarly, I'm kind of out of space, so I'm going to put my answer on the top. You're going to have this c from out front, from way back at the beginning. But then instead of writing 2c plus 1 separately twice, you could just do a little squared right here. Or you could write it twice outside, but I would accept both answers. So make sure you put your little C thing down. Don't forget your love. Don't lose your puppy. My one girl always says so. Don't lose this guy. Put him in your final answer. 14 is one of those perfect square problems. So I was talking with Zach. You always want one plus and one minus on your perfect square problems. What is the square root of 16n squared? Good. What is the square root of 25? And that's your answer. All right, we have 4 terms on our next one, so we're going to use grouping. I'm going to go ahead and make a pink group from my first 2 terms. Make a green group from my second 2 terms. And we're going to factor out a common monomial from each group. So what's the common monomial in the pink group? 4n to the second. You're right. Huh, interesting. So that's going to leave us with the 6n plus 1. And I kind of let that 6n lead the way. In other words, in my green group, I'm going to need to have a 6n plus 1. So what will factor out of my green group? -1. And -1. Good. Okay, this is why I like this step, just because I can do magic. Ready? Abracadabra, make a new group. These 2 form their own brand new group. 4n squared minus 1. Abracadabra, become one group. 6n plus 1. And I actually, when I made my answer key, I stopped here, but now that I'm looking at it, if you're super, super scholarly, you might notice something about this. Does anybody notice anything about this? They're both perfect squares, right? Aren't they? And they have a minus in the middle. So we actually can factor this using the technique we used on 14. I will have to redo my answer key. A 2n plus 1 and a 2n minus 1, because the square root of 4n squared is 2n, and the square root of 1 is 1. Tricky! That tricked me this morning. That's what I get for doing study or answer keys at like 6:45 a.m. I'm not quite awake.
What have you done?
If you don't end up doing that, I probably would still give you full credit, because you know I'm nice and you're freshmen. And we babied the freshmen a little bit. Now, if you get me in Algebra 2 2 years from now, you wouldn't have to factor this one step, or you wouldn't miss points. All right, we are almost done. We have our 2 solving problems. Find the zeros of this function. To find zeros of a function, you basically just replace the name of the function with a 0, and then you use your zero product property and solve it. So you would just set both your binomials equal to 0, like we did earlier. So set your 8x plus 4 equal to 0. Use the word or. Set your 6x minus 3 equal to 0. And now we have to use some solving techniques. So I will start by subtracting 4 on both sides, giving me 8x equals 4. I will finish it off by dividing by 8. What's 4 divided by 8? 1/2. Just a positive 1/2 for this one. Oh gosh, you're right. I lost my puppy. Thank you, thank you, thank you. You're right. You lose your puppy is when you lose negative sign. So it's -1/2. Thank you. I think it was TT that saved the day on that. Here you go, TT. Click it. I'm sorry. I heard her voice, not yours. All right, head over here. Do a plus 3 on this one. Get 6x equals 3. Divide by 6 to finish. Positive 1/2. So one answer is a positive 1/2. One answer is a negative 1/2. Two answers. Last one. How should I start off this last one? I was like, what if we would divide by 4 on both sides? I don't think that would ruin our answer. Do you guys want to do that? Or not? You know what you actually could do on both sides? Divide both sides by 4. It's still gonna work out the same. But yeah, we do need to get set equal to 0. I heard somebody say get it set equal to 0. You didn't have to divide by 2 on both sides, but that just kind of caught my eye as a possibility. I actually did not do that when I did it earlier, but we'll get the same answer. That's what I got. So we'll have a 2c squared minus c equals 0, and we'll have to factor common monomial. common monomial factoring. What is the common monomial in both of these terms? A c, leaving me with a 2c minus 1. And now I use my zero product property. Either c equals 0 or 2c minus 1 equals 0. So I'll solve this one by adding 1 and then dividing by 2. So thanks for joining us for our video. I hope if you want extra practice, you'll come to a study party tomorrow morning at 6:50, or even look at the study party problems I have on Polaris.
Okay, great.